Identify the domain and range of the relations shown in the graph, then determine whether it is a function. Here we're given the graph of y equals the opposite of the absolute value of x plus 2, and first we'll determine what the domain of this relation is. And as we can see, as this graph is going down, it's expanding to the left and to the right. So no matter what x value I pick, for instance, if I pick -5 as my domain value, x value, it has a point associated on the graph to that value -5. Well, no matter what x value I pick, as you can see, I will always go down and end up hitting the graph. So the domain of this relation would be all real numbers. So we'll write it in interval notation, -infinity to +infinity. The range, we'll do the same thing, but now on the y-axis. What values on the y-axis have points on the graph, and as you can see up top, positive values above 0, like for instance +3. If I go left or right, I will not hit the graph. 0 is a value where if I go over here to the left, I'm hitting the graph. So what are all of the range values? Well, coming from -infinity, I'll hit the graph up until I get to 0, which will be the last point going from -infinity to +infinity, where we'll hit the graph. So the range will be from -infinity up to 0. Finally, is this a function? And as you can see, this graph will pass the vertical line test. As you run a vertical line through the graph, the vertical line will only at most hit the graph at one point. So yes, this is a function. So it is a function. So our summary: domain, all real numbers, -infinity to +infinity. The range, -infinity to 0, and yes, it's a function.